Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Mwaka. I am your instructor. Today, I'll be showing you how to design a foundation for a concrete building using Protastructure software. So by the end of today's lesson, you will be able to use this software, Protastructure, to design any kind of foundation. But for today, I'll be showing you first how to design a part foundation. As you can see that this building, which is just one story building, is sitting on a part foundation, as you can see it here. And also this building consists also a cantilever slab, as you can see, and which the cantilever slab is already having a cantilever load. As you can see the load here, which is the UDL load, is already having a cantilever load at the edge of the cantilever. So if you want to know how to insert a cantilever slab and also apply the cantilever load on the edge of the slab, I would say you should check on most of our videos, because we have done a lot of videos on how to apply this cantilever slab. And also you can see also cantilever beams, as we also have cantilever beams in most of the places, as you can see, and also how to make changes when your first floor plan and your second floor plan are not the same. So we have done most of these videos in most of our lectures of our videos. I can also see cantilever beam here. So but for this lesson, I will be showing you the foundation design. This foundation design will not be like any other one that you have seen in most of my videos, because I will explain a lot of all the principles and guiding principles of the foundation design using Protastructure. So I will say that you should spare out some time for yourself so that you can be able to grab up what we have done for today. Okay, so let's begin right now for the foundation design of this building. So right now, I'll just go and leave on this place. I'll just go back to the plan view right now. On this plan view just now, I'll now go back to story 01. As you can see, story 01 here. Story 01. Now, if you want to begin your foundation design after you've fully performed your modeling and also perform the building design, the next thing to do, and if you check on this building also, you will see that if you check on our design status right now, you can see that we have already performed the building design for this building, and we have checked all the members, which confirms okay. As you can see that every members have shown green, and I've also told you what to do when after you're finished performing your building design, that we must have to check the buildings, all the members one after the other, to be able to see the kind of reinforcement that this software used to design your members for you. Okay, so once you've done that, next to do right now is now enter foundation design, which we are here for today. So I'll go back right now to my model view right now and go back to this place, and then once you're done, you have to go back to your plan view first, and on your plan view, to begin your foundation design, you have to click on story 00, because it's only on this level that we can perform our foundation design. So right now, I'll just make a two-way. I'll just make a two-way right now to show two-way for you guys, two-way views, so that you can be able to see what I'm showing. So I'll just make a two-way view right now and make it vertical view this way. I'll just close one of these down and then just have one view, and I'll just drag this down here. The reason why I'm doing this is so that you can be able to flow up when we are going to insert our foundation footing. You'll be seeing it here live on this 3D view. So right now, to perform the foundation design right now, I'll just delete all the ones which I have here already and then show you how to perform the design. Okay, so right now, I'll just go on this place right now and click on this first column here. I'm doing this to be able to take off all the ones which I've already done and show you how to perform it. So I'll just click here right now and delete this footing. So right now, once you're done with your building model and also you have done the design, this is how your model will look like with that foundation. So it is now your right as a structural engineer to now perform the foundation design of that structure or that building, following the soil reports. Before you must do your foundation design, you must have your soil properties, which is your bearing capacity. It is only from that you can now be guided on the type of foundation that you will use. In this case, because this is a live project, the foundation, the soil bearing capacity that was given to me as a structural engineer for my client, Engineer Tega, was 125 kilonewton per meter square. So that is the bearing capacity factor that was given to me, is 120 kilonewton per meter. So right now, I'll just click on this place. So right now, to now begin your foundation design right now, the first thing to do on this your plan view on SOE 00, as you can see it here, you click on one of the columns, then right click and then click on insert part base. Now on this insert part base right now, a dialog box will appear which will now carry all the foundation footing parameters. So on these parameters right now, the first thing to do is to assume your foundation depth. Sorry, your footing depth. Your footing depth is always assumed. So you as the structural engineer will assume that footing depth. Now what happens is that on your assumption, you will be guided in some principles. So I always advise that your minimum depth for your assumption should be 250 millimeter. So right now, I'll use 250 millimeter first as my first initial footing depth and my first assumption. And if it is not sufficient, then we can now go and increase. Then, so once you inputted your first footing right now, the first thing to do is to do again, leave this place as default, 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 and default, and then you move over to this place called the allowable stress of soil, which simply means the bearing capacity. So right now, on this place right now, you have to input your bearing capacity, the soil bearing capacity of the area where this building is to be sited. So in my own case, the bearing capacity here is 125 kilonewton per meter square. So right now, I'll just input my value there, 125 as my bearing capacity. Then once you have done this right now, the next thing to do is to now go to this place called T-bars. You have to now select the type of the side of the reinforcement for your footing. Now, I will advise you, because you also have to make your choice on this area. Now, if you're designing for a one-story building, I will advise that you use diameter 12 as your size of your reinforcement. Now, because it's a one-story building, but once you're designing for a two-story building, I always advise you use diameter 16 because of the weight of the building. Now, because this is just a one-story building and having just one slab, and the soil bearing capacity is not that bad, I'll use diameter 12. Now, in my next video, I'll tell you what to do when your bearing capacity is very low, at least around 90 kilonewton per meter square, and you still want to use a pad foundation. Then I'll tell you what kind of reinforcement size that you are going to use. Virtually, it won't be diameter 12 any longer. Okay, so right now we will now go. So once you've inputted your footing depth, you assume footing depth, and then you put your bearing capacity factor, which you get in your soil test, and then you assume and you put in your size of your reinforcement for your footing. As you can see right now, it is showing not calculated because we have not yet done the footing calculation here, which is the design. So once you have done all these inputs, the depth, the bearing capacity, and then choose your size of reinforcement for the X and Y direction, next to do right now is to now click on this place called calculate. Automatically, it will calculate the footing size for you and also design the footing for you. Now, once you come to this dialog box right now, the first thing to do right now is to now click on this place called square footing. Now, on this square footing right now, you will see the size automatically, the size of the footing. As you can see it here, LX is 1.3 meters and LOY is 1.3 meters, which gives us a square footing. As you can see the footing here, and the column inward here, as you can see there, and the column is perfectly centralized. I would say that you should not put any value here, because once you put any value here, you are saying that the footing that the column is not at the middle of the footing. Let me just show you as an example right now. If I put a value here 10 right now and click on this place, you can see that, or let me say 200. This column will shift from the center of the footing, which is not okay. You can see that. So this is being shifted from the footing, from the center of the footing, which there is a condition which you will do this kind of thing, and I'll tell you as we go on in this video. So right now, as you can see that once we have increased our footing eccentricity, as you can see it here, the size of the footing has increased to 1.7 because it is trying to shift the load to one side of the footing. But I will show you when to use this kind of foundation where you have to shift your column to one side of the footing. But for right now, we want to centralize our column at the middle of the footing. So we'll just go here and then put 0 at that place. That means that our column is sitting directly at the center of this footing. Then right now again, once you have checked this place as square footing, next thing to do right now, leave everything here as default and then come to this place. This is the place where if your building will fail in foundation, this is the place where it will fail and all these places. This is called pointing check. Now, if the footing size, if the footing depth that we put here as 250 is not sufficient, you will see this place will be showing failure. I'll show you a typical example when we will do that. Now you can see that because we made that changes of putting column shifting of 200, the value of this still remains now. Okay, now it's back to 13. Okay, so you must check this place on this punching check area. This place must be okay. This must be okay, and this must be okay. Listen very attentively. Don't say that you're rushing on this area or your client is in your neck to issue this work. No, you must check on this place area. Once this place is not okay, I will advise you go and increase your depth of footing. And if your depth, there is a level at which you increase your depth of footing, and if you're still having failure, I will advise you make a change of foundation from footing to a wide strip foundation or to a raft foundation. And I will tell you on that in our recent videos which are doing. But if you want to know more, there's what we call Ekidel mentorship program, which we are already training most subscribers. And I will say that you can join our Ekidel mentorship program where we'll train you specially using Zoom app, like and it will be a live screen training. And after the training, we will send you video of each particular day that we have trained you. Okay, it's very, very important. Also, if you want to carry the structural engineering career or civil engineering career to the next level. Okay, so right now, you must make sure that this place is okay. Here must be okay, and here must be okay. Except here is, if here is not okay, and here is not okay, and here is not okay, and you're seeing anything failure, you must have to increase your depth of footing or you change your choice of foundation. Don't go and decrease the bearing capacity, because the bearing capacity is the bearing capacity that will carry the structure. All you have to do is to go and increase your depth of footing. And if you have increased your depth of footing to at least 500 millimeter, I would say at that and the footing is still failing, at that point you must go and change your choice of foundation from pad foundation to either strip foundation or raft foundation. Okay, but for now it is okay at 250 depth. As footing depth is okay at 250, and everything here shows okay, okay, and okay. And on this area of steel reinforcement spacing, and as you can see that once the value of your spacing is more than 100 millimeter, I will say that your foundation area for reinforcement is okay. But if it is below 100 millimeter as your spacing of reinforcement, I will say the same thing. You should go and increase your depth of footing here. Okay, so knowing that right now, once you have checked this is okay, and this is okay, and this values here for the spacing of reinforcement is more than 100, then you can now click on this place called OK and then OK. Automatically, you will see our footing depth already. Yes, you can see it here right now. We have successfully inserted our first footing for this building, as you can see it right now. So we go ahead right now to now click on the next column right now. As you can see that already selected inside here. Right click here and say insert pad base. Now once you have done your first footing foundation, you don't have to make any changes here any longer. All you'll be doing is calculate and then check. Square this place and then check on this if this is okay. Now, since I've already explained to you guys what to do, that's why I took my time to explain to you on that first place. The next thing to do, once you have done your first footing design, next to do is to just be checking this if this is okay, okay, and okay, and check your spacing if this more than 100 millimeter. You can now click on OK and then OK. You can see we have done our second footing, as you can see it here. So I will increase my speed or my pace on this so that I can save time on this video duration. So I'll now click on this place again. On the next column, I right click and say insert part base. So the same thing you'll be doing, all you have to do is you'll be checking your square this and check if this is okay and this okay and this okay. Once this is okay and they are okay and the spacing here is more than 100, you can click on okay and then okay. Now let us do a typical example of when your foundation footing is failing, what to do. Now I'll just typically go and decrease my size of footing depth from 250 to let me use 100, and let's see if that will fail, will cause a failure. Now I can see that this is failing, as you can see. So once you experience this kind of failure, even if you square, it is still failing. Once you experience this kind of failure in your foundation design for pad footing, I would say that you should go and increase your size, your depth of footing. So with this right now, don't go and say okay, because if you say okay and go and say okay, it will insert the footing for you, but that building will collapse. So I'll say you should go and increase to 250. Sorry, that's why I say always use your minimum to be 250. Okay, I will now go and say calculate, and then you can see that everything now becomes about okay. So this footing depth of 250 is able to withstand the axial load coming on this footing, and the axial load from that column coming on this column is 182.427 kilonewton, as you can see it here, and the moment on X is 0.55 meter, and on Y direction is negative 0.97 kilonewton meter, as you can see it here. So we now click on OK because that's okay. So with this right now, since I've already shown you when you have a foundation, a footing that is failing, what to do is to increase its depth. I'll just make it faster so that I'll reduce the length of this video. So I'll just be checking, but even if I'm fast, I'll still be checking all the check-ins, the punching check if it's okay, the shear failure if it's okay, and this is okay, and the spacing is okay, and I'll go okay and then okay. And I'll go again right now, continue again, click here, right click, and then say insert part base, click on this, and then okay, and then okay, and then okay. Now I'll show you again what to do when you are having oversized base. Let me say in my next video, I'll use a bigger structure. There are some cases if your size of your footing is very big, I'll show you what to do. You can do without the moment, because there is a formula in all design code that we uses axial load to size our pad foundation and not moments. Moments are used to design for the reinforcement and also axial load, but for the sizing we only use axial load, which the formula is the axial load divided by the bearing capacity. Square root of that answer will give you the size of your footing. So go on and click on OK. As you can see now, okay, we have done almost, we are still going. So I'll make it faster right now. Click here, insert part base, and then click on this calculate, and then check my spacing, check all these spacing. They are okay, okay, and okay, and my spacing is okay, and then okay and okay. Okay, so I'll just be a little bit fast right now, and click on here, right click, and then increase here. Click here. Now, if you want to increase your depth of footing, your size of footing, you can also increase it here by 1, you can see it here, but don't decrease because there'll be failure. Okay, so just increase. You can also increase if you want to have a uniform value, but just that your design will not be economical, because if you increase your size when it gives you 1.1 as your size of your footing and you make it to 1.2, indirectly you're increasing the cost of the building for the client, and it's not economical. As a civil engineer or a structural engineer, your main aim is to make the building stable and also consider the cost of the building. So you must have to reduce the cost at all costs, reduce the cost of the construction of the building, while you also consider the stability of the building. Okay, so right now we'll now go and click OK and then OK. And then right now we will now click on this one. Let's say I click and then say, now I'll also show you in my next video also, if you are having two columns, two footings overlapping, what to do is to do a combined base. There is a special way of performing a combined footing which I don't know if anybody have taught you before, but there's a way that there are rules in command footing which also applies in this software Protastructure. Because if you want to be good in software engineering, you have to pass through a hand or someone or a boss that has experience of over 10 years. And here in Ekidel, we have engineers who are already having 40 years experience. As for me, Justice Walker, I already have 11 years experience in structural design. I started my design I am my design stage in 2012. So you can calculate how many years of experience is that, and this is already 2022. So you should see that that's already over 11 years experience. Okay, so right now I'll go again and do that. And also here on Ekidel, by next year, 2023, we will be introducing another software called Protastructure because we have been doing a lot of concrete designs. So we are about to enter steel design where we will use Protastructure to perform the steel design, and then we will use Protastructure to perform the steel detailing because Protastructure is not that good in steel detailing. So we will use an advanced software which is Protastructures so to perform the steel detailing, which we will take the design parameters from the Prota structure, which we designed using the form using the design codes. So we will use Tekla structures to perform the detailing of all the steels which we are going to design for. So that's why, since I've mentioned that right now, if you're a follower of Ekidel, I would say that you should find a way to install that software, Tekla Structures, because we were able to enter install steel design. And I know most of you have gained a lot of knowledge in already concrete designs, and which most of you have already started making money in structural design by the help of Ekidel. Our mission is to make sure that that we train good structural and civil engineers, so that in future, when I'm old or when I'm up to 60 years, when I'm weak in design, if I enter any hotel, I'll be rest assured that that hotel was designed by a capable hand. So that's why we are doing all this. Not that, because we have seen that most good engineers are already leaving the area and we don't have good engineers again. So we have given our life to be able to train good civil and social engineering, because that was how we were trained. So if we are not trained to this standard, how then do we impart knowledge to others? So because we are trained from good hands, we also want to impart the knowledge freely to good hands. That's why you can see that we don't sell any of our courses. We are doing very high classified professional intensive classes and lectures on structural designs free of charge. That is why you can see that most of our subscribers keep on coming to our WhatsApp platform telling us thank you for the good lecture that we are giving out for free. Most people go and put all these courses, most of their courses in most of these paid courses softwares like Udemy and Linda, and they make money from that. But why will I take money for the knowledge I want to impart on the younger engineers? Maybe you can go ahead and take money, but our culture here at Ekidel, if we get knowledge free of charge, we impart it free of charge, and we don't take money for giving out any of our videos on YouTube. But if you want us to train you specially, like our Ekidel mentorship program, then we can now you will not pay for that mentorship program. But for all our videos here on YouTube, is free of charge. Even if YouTube make their next update, which they say they will make, that they will be having paid courses, we will still be giving out our videos for free. Okay, so you can now see why I am talking. I am still checking all these things. I'm checking my quantity check if they are okay. I'm doing all these checkings. So don't think I'm not doing that. So even if you're busy, make sure you're checking all that things, all those checking. Check for pointing check and check for share failure and check for your spacing of reinforcement. Okay, so you can now see we are almost done with our footing design, and and I'm sure that this is a very high classified and intensive lecture on this part, foundation design. Maybe if you still have any question regarding on what we have done and you're confused in any area, you always drop your comment right down on our WhatsApp platform, or you drop the comment right down on this video, and we will reply you in less than 10 minutes. We have always keep up that standard and replying all our subscribers on all their comments in less than 10 minutes, and we have done that for the past 6 months right now. Ekidel is just 6 months old as of today. We are just 6 months old, and soon we will be celebrating our 1 year um, anniversary. And I will say to you that without your help, all our subscribers, and without you watching this video, we won't be here today teaching you guys all this. So thank you so much for you finding our channel and subscribing to our channel, and also following us up on all our uploads, and also sharing all our videos to um, all your platforms on social media, and also recommending all our channels to your colleagues if you're a worker, and also to students if you are a student. So thank you so much, and we love you, our special subscribers. Okay, so right now you can see that we are almost done. As you can see, all the changes we are making is showing here directly. So let us insert this right now. You see how it will show here automatically, and click on the design and do this and check on this. They're all okay, and then okay and okay. So in our next video, we will be performing the full structural detailing for this building, and we will be using an automatic template which helps you to perform your detailing perfectly, that which also reduce your workload to at least 80%, and that template is called Stonebridge Company Structural Detailing Template, because Protastructure does not perform detailing very neat. So a company called Stonebridge have to customize a template a template in AutoCAD, which helps you to, now once you're done with your design in Protastructure and export your details, you just copy your details into that template, and automatically it will rearrange everything, all your details for you, to a printable way and to a standard way of global structural detailing standard. Okay, so right now we are almost done with inserting all our footing base, as you can see there. So in our next video, we will be performing a pie foundation, and we will be using other type of structure in performing the pie foundation. Okay, so you can see that this is our last footing that we are trying to insert right now, and everything must be okay, okay, and okay, and then okay. So you can now see that we have successfully done our foundation design in less than 30 minutes. As you can see that the time, 30, this is already 27 minutes past, as you can see that. So we have successfully inserted all our footing, as you can see there right now. So with this, I will now click on this place right now, as you can see now right now. So we have performed all our foundation footing, as you can see here right now. In my next video, I will show you how to export your foundation reports, your design report, because every checker or any good engineer checking your design, what you ask for is your foundation design report, or what they call calculation sheets. So I'll show you in my next video how to print out or export your foundation design reports, and also your column design reports and your full design reports, and we will also export these foundation details into Protastructure, into Prota details, and then perform the full structural detailing. So thank you so much. As you can see what you have done. Now, if you find this video very, very useful, I would say you should please click on the like button, like this video, and also subscribe to our channel if you have not yet subscribed. And if you have already subscribed, I say thank you so much for subscribing, and thank you for sticking to our channel. We love you, and we will also be helping you out in all the area. Now, if you want us to do any type of design, I would say you should just hit us up on our comment section, and we will take that into consideration. Okay, and also we will be coming up on this channel and a 30-story hotel building, which will be coming up in this month of November, by at least towards the month end, because we have got a live project to design a 30-story building in for a client in Italy. So we will be designing, and that will be carrying an earthquake load, because no earthquake occurs in Italy a lot. So that will be having an earthquake load also. So I'll be showing you all that. So thank you so much for now for being to the end of this video, and God bless you, and we love you. And Ekidel loves you so much, and thank you so much, and God bless you. So I'll just go and click on save right now, and then I'll click on, once it's done saving and we have done our foundation design, So thank you and God bless you. And don't forget to subscribe if you have not subscribed. And please recommend our channel to your friends and tell them what we are doing right here on Ekidel. And we love you so much and God bless you. Okay, bye for now.